On page 271 of your book, figure 4.1.2, you're going to see a short table of Laplace transforms. So what I want to do right now is I want to calculate some of these Laplace transforms using the definition of the Laplace transform. So again, I want to calculate Laplace transforms using the definition. We're going to be using, you're going to have this nice table probably on your test, but it's important to understand, why the formula is the formula, why the Laplace transform of 1 is 1 over s. So let's go ahead and just start with, so I want to show you where the Laplace transform of 1 comes from. So according to our table, right, the Laplace transform of 1 is equal to 1 over s. Okay, so I want to prove this to you using the definition. So, right, this is a proof. So we have the left-hand side, right? This is the left-hand side, and we want to prove that it's equal to the right-hand side. So we have the Laplace transform, right, of our f of t, right? Our f of t is this guy right here, happens to be a constant function. Okay, so by the definition of the Laplace transform, we have, right, so our improper integral. So we have the integral from 0 to infinity of e to the negative st, okay, times our f of t, but our f of t is just 1 in this case, so it's very nice. Anything times 1 is the same thing, so we end up just getting this exponential function. Okay, so we know we're going to integrate e to the negative st, right? This is our integrand, and this is just going to be, s isn't some arbitrary constant, right? It's going to be strictly greater than 0, and we'll see why at the end. But this is just going to be e to the negative st, right? And we're going to be dividing it by, right, the derivative of negative st, right, where t is our variable. So this is just going to be negative s, right? And we still have our upper and lower limits. And I'm just going to go ahead and rewrite this as negative 1 over s e to the negative st from 0 to infinity. But we can't, evaluate infinity, so we know we're definitely going to write the limit as b approaches infinity. And we're going to take this guy, so negative 1 over s e to the negative st, right, from a to b, and my a is 0 in this case. And then this guy is going to be my b. So, and using the fundamental theorem of calculus, right, we can evaluate these values are 0 and b, and I'm going to go ahead and just write my limit. And remember, this is a function of, this guy's a function of t, so we're going to, we're going to input our b, e to the negative s b minus, and that's really minus, let me just go ahead and write it, minus 1 over s e to the negative s times 0. Okay, so we have the limit as b approaches infinity, and then we have negative 1 over s e to the negative sb or bs, it doesn't matter. And this guy's just going to be positive, right? And we have 1 over s, and then we have e to the 0, but remember, right, e to the 0 is just 1, so this is just 1 over s. And then now let's evaluate the limit, right, as b approaches infinity. So as b gets very, very large, and if you want, we can actually, this is a good review, right, we can take the limit of each piece. And, well, we know the s is a constant, so the limit, right, of this constant is just 1 over s. And as b gets very, very large, right, and here's our b, and this is an exponential function, right, so it's we're focusing on the b here, not the s. The s is some arbitrary constant. So as b gets very, very large, right, what happens to e to the negative s over b? Well, if we look at e to the negative sb, right, it's our power is negative, so that means our function is going to look something like that. So as b gets very, very large, right, the function, the limit is approaching 0. So, I mean, this whole guy is 0. And so we get 1 over s. And so let's maybe write, so we've proved that the Laplace transform of 1 is 1 over s. And so that's basically it, using the definition to prove this. And we can do this with the Laplace transform of t to the n, any of the f of t's in that table. And you'll be asked to do that in your homework. I'll just give you, not too many, just so you have an idea of how to use this definition. So hopefully that makes sense. And I'll do another example in the next video.